Welcome to the second half of the video. So we were discussing about system modeling, and I'm going to continue with the lecture now and move on. Uh, let's see. In the next part, in the second part of the system modeling, we're going to look into these diagrams one by one now, starting with the activity diagram as the first one. So before doing that, let's look at the graphical models. There are many reasons why the design of a project is basically done via graphical nodes. Some of these we already discussed, but let's repeat them as they are mentioned in the book. The first one is that as a means of facilitating discussion about an existing or proposed system, something that I already mentioned. Incomplete models are okay as their role is to support the discussion. So once again, the diagrams itself, they do not have to show every single detail. Particularly validation is most of the time is skipped in system modeling, and you can do it for existing system as well as the new systems. But technically, their purpose is to make sure that everyone is on track of the project, up to date, and they know what they are doing. This can also be used as a way of documentation. So something that maybe I didn't mention enough is that you can also use the documentation, system modeling. You can use this as actually the agreement between your stakeholders, something that we mentioned in the requirements process. Remember that when you decide the requirements, you form the basis for a contract. So now that the system you already discussed about what has to be done, now you show them how the system will achieve that. As a detailed system description that can be used to generate a system implementation. This is the part that probably concerns you the most, because if you're going to be software engineers, you need some kind of a map or a schedule to show you what you need to do in order to achieve that. So these are giving you the details of the software in terms of what kind of interactions would exist so that you can implement these interactions. There are two aspects here that you should focus on, the interactions and the structure. Sometimes the interactions can also be referred as the behavior of the system, and the structure itself basically is the scaffold or the skeleton of the system. These interactions basically highlighted with three different diagrams. One of them is the activity diagram, which we're going to see today. The other two are the use case diagram and the sequence diagram. Each one focuses on a different aspect. The activity diagram shows interactions through data flow from one to the other. In the old days, instead of activity diagram, people use data flow diagrams. But the UML specifications, as I told you, change over time. Now activity diagrams replaced the DFD diagrams. So DFD diagrams are no longer used, not that much anyway, and instead they are replaced by the activity diagrams. The use case diagram is the next one. This is often used. You may see this in many places, and they are used to express the system to a manager, for example, or sometimes to a person who are not really engrossed with the complex activities of software engineering. They do not need to see the details, but rather they want to see the interactions that is happening on the system. So it shows what kind of functionalities will happen and who interacts with the system, and how do these things go through as a big picture, but doesn't give you an idea of the internal communication of the models, which is done in the next diagram that is called the sequence diagram. The major difference between use case and sequence diagram, which we're gonna look into it in the future, but in the sequence diagram you have an order. That's why its name is sequence. So there is an order of activities that happen, where in use case you do not. And the second thing is that you can show a lot of details about the models here, such as validation. You can even show a looping phase. You can even display data handling and the places the data is stored, as well as exception handling. So many of the details that you did not show in the use case are actually displayed in the sequence diagram. They usually both go together. So basically you start building up the system using a use case, then you develop the sequence. When we talk about the interaction of the system, we talk about, of course, the behavior of the system. And inside the behavioral models, there are two aspects that we need to be aware of. First of this is the data. The data arrive that has to be processed by the system itself. And the second thing is the event that triggers the system processing. These are usually associated with the data itself. So you can think data as the system input and the output, and the processes that happens are called the events, or they trigger events as an output of data being processed. This is the core of all behavioral models, such as activity, use case, and sequence diagrams. So whenever you have to deal with any of these three diagrams, you need to make sure that your data will be processed, and this will generate some events. The first diagram on the list that we're going to cover today is the activity diagram. Let's look up what the activity diagram is. Activity diagram is the first UML diagram used to describe dynamic aspect of the system. It is similar to flowchart, as I told you, and there's a start and there's an end to it. And just like in the flowchart, it goes from one activity to the other. It does even have gateways that you come to a decision point, just like an if statement, and it can branch into multiple pathways. This is why many students confuse activity diagram with the flowchart, and they fail even to see the difference. And they keep telling me that, oh, this is exactly like a flowchart. There's nothing in difference. However, there's one aspect that is different in the activity diagram. That is, in a flowchart, the data has to broken down step-by-step approach. And you cannot actually jump into a step unless you deal with the current step. So it goes from one to one, and the activities themselves are actually not concurrent. It has to be, consecutively one after the other. However, this is not true for the activity diagram. You can actually execute activities themselves or the data flow parallel to others, and it is possible to display concurrent activities, which means those activities that happen at the same time. So this shows the big difference between activity and flowchart. Flowchart is not an ideal way to show synchronous data. The data here is never processed in a parallel manner. It is unparalleled, which means it has to go step by step, and you cannot pass into the next step unless you deal with the current one, where this is not always the truth. The activity diagram can show the parallel, the branched, fork, concurrent, or even single activities. And it doesn't need to, show them as one after the other. It can be the case that these are happening at the same time. Another confusion that happens on the student side is that they assume that activity diagram is the same as network diagram because their names are very similar. Remember that activity diagram is a UML specification right now. It is part of the UML design, so it is used more with the software industry. And no other industry, as far as I know, they use them as much as we do, where the network diagram is not something specific to our field. Many of the industrial engineers actually, they use network diagram. Again, project managers, they use network diagram or Gantt charts. It is more of a tool in the project management category rather than software engineering. It is not specific to our discipline. It can be used to manage a project in manufacturing, for example, or engineering in terms of civil engineering or machinery or other parts. So this means that the network diagram is not something that's specific to our field, but it is rather a practice used for project scheduling and management. Are we good so far? Just to summarize, the purpose of the activity diagram is to draw and show the activities themselves. We can describe the activities sequence by sequence from one activity or other, but we can also describe these activities parallel, branch, sometimes called forked. There's actually a symbol called fork in the activity diagram. And you can also show the flow of the data as concurrent, which means happening at the same time. To draw the activity diagram, you should be fond of a couple of terminologies, which will help you throughout to recognize these symbols. The main element of an activity diagram is, of course, the activity itself. These are represented as actions. After identifying the activity, you need to understand the association, the constraints, and the conditions. These are also an integral part of the activities themselves. So basically, an activity is something that happens when data flows into the activity diagram. And the outcome of these can be the associations, conditions, or constraints. Once the above parameters are identified, a mental layout can be drawn and you can start forming the activity diagram. In the activity diagram, there are several controls that you should be aware of. First of all, every single activity diagram will start with an initial node and end with a final node. These are usually represented as circles. So this one, the open circle is the initial node. The circle that has another circle inside with the filled circle is the final node. The action is represented as a process inside the activity diagram, and decisions are basically gateways, like this. So the data flows there, and it can go into a branch, should you want to. You can match the forks, you can join them, and you can combine them. So if two data basically comes into a point and leave as one, this is called a merge process. The opposite of this, which means come to a point where two data leaves at once concurrently, this is called a fork. Essentially, this could be more than two, could be three, or what. It represents like a fork symbol. You can see it on the screen as I draw it. You see, there's a fork, hence this is called a fork node. And it is also possible to join these. So it is possible that concurrent activities come and leave as concurrent activities. These three nodes here is what makes activity diagram much different than a flowchart, because it is not possible to show concurrent or parallel activities in a flowchart. There is one final note that is not frequently used that much, but it is still nice to know. And it basically divides your job into rectangular areas so that you know which activity is taken under which category. That is the purpose of the swim lane. So let's look at them one by one, their symbol. So these symbols are actually taken from Visio, a software that I use in the lab. I don't know if there's a community version of it right now, but it used to be part of the office. So you can actually, if you have a licensed office, and as a student of, as far as I know, as a student of our university, it is possible to get a licensed office for your computers. You can ask Devrim Hoca about it because he manages this stuff. And Visio is actually as part of that license. With the Visio, you can basically draw these symbols as are displayed in here. And the symbols might slightly change according to the software you use, such as I use Lucid Graph, and they are a little bit different, but more or less they are the same thing. So if you basically extend in the Lucid Graph the nodes for the activity diagram, you will see that these nodes are very, very similar to what is displayed in the visual. So as you can see, that is a start node, which is the initial node, and this is the end node, which is the final node. So every single activity diagram, I'm going to maximize this so you can see, every single activity diagram starts with a start node and ends with an end one. Just if you go over them, you will see the name of the symbols. Not every one of them will be used in here. Many of them we won't use actually, because each software deals with a different way. But these are the names that we will stick using when drawing the activity diagram. Next, we have actions. So I'm going to go down and look into the action. Actions are activities that show the system flowing from one state to the other. With each activity, the system basically builds up to work. Each action can only go from one to the other, unless there is obviously there is a fork or something else in between. Action usually start with a verb. This is the crucial part that you can differentiate an action from all the other nodes. They are taking a verb, such as take order, register user, login, something like that. These are all verbs, as you can see, and it will help you out to differentiate an action from regular nodes. Next, you use a decision, also called a gateway. This is a control node that will help you to basically decide, take an action based on the incoming data. There is an incoming edge and an outgoing, and it works very similar to the flowchart. So each taken arriving at a decision can traverse from only one end, and it goes from the other. Here are some examples that you can see. So the big difference here is that it's not always a yes/no scenario like in what we call in flowchart, but it is actually branched into more categories, as you can see. It's like priority 1, priority 2, else. Usually when we deal with it in a flowchart, we take them like one decision at a time and branch them in the decision node. In order to simplify this process, we use one node only and in the activity diagram, and we can branch it as much as we can. Unless it doesn't look messy, you can use this. The merge one is used to basically merge, which means combine, concurrent, the activity, the data flow. So this will allow you to basically use, again, a diamond shape. You can combine these data flow into one, such as if you are asking a user to enter their name, their username, and you want also them to enter their password. These could be regarded as two different data, because password is a different data, username is different data, but essentially they go to the same interface, which could be the login interface. So you deal with two different edges, one that is the username, the other one that is the password, all together, username and password, going into the activity to log in. That is a good example of how you can merge it. The merge and decision can be used together. It is possible to do that, although I don't see this very often unless you are designing a complex structure. It is possible that you can do this. Usually, I prefer to keep my activity diagram simple and understandable. So unless I am forced to, I will not use merge and decision, but I will keep them separate. Okay. But there are cases on the internet, those who might be curious, they might look upon. So if you see a merge and a decision being used together in an activity diagram, it doesn't mean that it's wrong, but it's a very, very rare case. I don't see it that often, and I doubt you will see it either. The next one is the fork. This is an often used one. It is basically drawing a fork symbol, just as I mentioned, and they are particularly used for multiple concurrent flows. So in this one, multiple outgoing edges, they are basically come from an one flow and divided into different parallel activities. So these activities can happen concurrently. Okay. Like I said, one of the big differences here is that the flowchart cannot handle parallel activities, where the activity diagram can do that. And as you can see from the diagram, it generates a flow, a fork shape, so that this might help you recognize a fork node. The join, of course, is the opposite of this, exactly the opposite. So this time, instead of generating multiple concurrent activities, those multiple concurrent activities come into one place and generate as a single activity. One of the things that is often hidden or kept abstract is that all these synchronous activities must be completed in order to generate that single activity. That is, for example, a detail, an abstract representation that is hidden in the activity